We're here at Utah State University at the Utah Water Research Lab in Logan, Utah, doing a physical model study of the proposed modifications to Isabella. So it's a 1:45 scale model. It's a great visual tool to verify the design, the proposed design will work how we want it.
A significant amount of effort went into building this model. A lot of manual labor work, and some heavy equipment. It's roughly about the third the size of a football field. It took about 8 weeks to construct. We had machine shops involved making parts. We had a lot of hand labor placing fill material and setting templates for the reservoir topography. So the main components on the most upstream side, we have the head box, which represents the reservoir. And then downstream of that, we have both spillways. We have the service spillway and we have the proposed emergency spillway, and then both exit channels to those spillways. Isabella is a very unique structure and required some solutions that are outside the handbooks. One of the common problems with reservoirs currently is undersized spillway capacity. If the largest predicted flood happened to occur and they don't have enough spillway capacity, there's a potential for a dam failure. We had to go back and look, what's the most flow we can get in the smallest amount area we can. We only have 800 feet, so we smashed the weir in there, kind of an accordion style. We call that a Labyrinth weir. We get a lot of discharge in a very confined space, so it's fairly cost effective. So today we looked at a variety of discharge conditions, 70,000 up to 500,000 cubic feet per second. The maximum flow that we put through the model today was 506,000 CFS. That would be the absolute biggest storm you could absolutely possibly get. This is probably the coolest model that we've built. The craftsmanship and the materials used and the intricacy of the design. If I can drop the water there by 10 feet, I think I'll solve my submergence problems. The model is important because it's one of our primary design tools to verify that the design does work how we want it to work. Once you see it, you understand it. So it's a great tool for understanding the physics of these problems. We can find problems, we can fix them so that it will work properly when we build it.